Electrabel has 7 nuclear power plants, 4 in Doel and 3 in Tihange, covering half of the electricity consumption in Belgium without producing CO2. But how exactly does a nuclear power plant work? A nuclear power plant works to a large extent like a conventional thermal power plant. Water is converted into steam, which drives a turbine connected to a generator. This generator converts the mechanical energy into electrical energy. The only difference is that the heat, which converts water into steam, is produced by nuclear fission and not by burning coal, natural gas or biomass. The nuclear power plants of Doel and Tihange use fissile uranium oxide. Uranium oxide is compressed into fuel pellets and packed into seal fuel rods. Multiple rods in turn form fuel elements which are immersed in water within a reactor vessel made of 20 cm thick steel. The reactor vessel is subsequently hermetically sealed. The fission of the uranium can now begin by bombarding it with neutrons. In each fission, 2 or 3 neutrons are released. They in turn cause new fissions and thus creating a chain reaction. In a nuclear reactor, it's important that this chain reaction is controlled. After each fission, only one released neutron should cause a new fission. Boric acid in the water of the reactor vessel and lowered control rods absorb the oversupply of neutrons. By lowering all the control rods at the same time, the chain reaction is stopped within 1.3 seconds. A nuclear power plant with a pressurized water reactor, such as Doel and Tihange, has 3 completely separated water circuits: a primary circuit, a secondary circuit, a tertiary circuit. In the primary circuit, the heat released during the fission of the uranium nuclei heats up the water in the reactor vessel to the temperature of 320 degrees Celsius. The pressure regulator keeps everything under high pressure, so the water does not boil or form steam, hence the name high-pressure reactor. The hot water passes via the primary circuit to a heat exchanger or steam generator. This is a cylindrical device with thousands of pipes in reverse U shape. The water runs through these pipes and gives the heat to the water of the secondary circuit, which flows alongside the exterior of the pipes. The water in the secondary circuit heats up and turns into steam. The steam from the steam generators drives 1 or more steam turbines. These turbines consist of a series of blades installed on a shaft. The high pressure of the steam causes the shaft to rotate very fast. This in turn drives a generator, which ultimately produces electricity, somewhat like a dynamo on a bicycle. Transformers increase the voltage of the electricity produced by the generator, allowing transportation of the electricity to the end users with as little loss as possible. To cool down, the steam coming from the turbines passes through a condenser. The cooling water from the tertiary circuit passes through the tubes of the condenser. In Doel, this cooling water comes from the Schelde, in Tihange from the Maas. The steam from the secondary circuit condenses to water and is returned to the steam generator to be heated again to steam. The warmed cooling water is brought to the cooling tower. There, it cools through contact with an ascending airflow, the natural chimney effect, as it were. The majority of this water is collected in a basin at the bottom of the cooling tower and then returned to the condenser. Almost all the water is subsequently discharged back into the Schelde or the Maas. Only a small part leaves the cooling tower as water vapor.